Hi everyone. So my name is Artsem Prashkovich and I'm really glad to be here again. And today I have a new presentation and I'm going to share it with you. And today we will talk about probably all possible ways to run Sitecore in Azure. So we will talk and compare these options. We will talk a bit about the deployment and how deployments looks like in general for different approaches and hosting variants, and we will look at the GitOps definition and describe which tools we can use to implement it. And of course, we will talk about the Sitecore Managed Cloud and Kubernetes. So I think we will talk a bit more about the Kubernetes because Kubernetes underline the managed cloud, and it is impossible to explain how managed cloud works without understanding what is Kubernetes and how actually Kubernetes works. And let's start. And the first slide is about me and just a few words about my experience, which is actually more than 11 years in programming experience. And since April 2012, I worked for Brimit, and actually I work for a Poland branch of Brimit, and actually I'm living in Poland. I have more than 10 years experience in Sitecore, and I was awarded as a Sitecore Technology MVP 5 times in a row. And I think we are ready to start the main part of the presentation. And first slide is about the options that we have to run Sitecore instance in Azure, as well as on-premise. And in the light rectangles, we have the infrastructure parts that we are responsible for as a developer, as a solution owner. And in the dark rectangles, we have the parts that the provider is responsible for. And actually, looking at the on-premise on-premise option, we can see that as a user and as a developer, we are responsible for all parts of the solution and infrastructure as well. Beginning from the hardware, network, and security, everything. So on the right side, which is SaaS, service as a service, we are responsible only for data. So Sitecore already provide this option, so we can use Sitecore as a SaaS platform, but it was released just a few days ago, and unfortunately, I haven't chance to look at it, and we cannot say a lot of here. But three main options that we can utilize to run our solution in Microsoft Azure. It is infrastructure as a service, or IaaS. This is Kubernetes or containers as a service, as well as platform as a service, or PaaS. So all of them a bit different. In IaaS, we are not responsible for, and we don't think about the hardware, networking, and our responsibility starts just from the operation system. For the containers, the operation system is a part of our containers, and we are just deploying our application there, and we are responsible for the application and data and everything which is related to that. So, and as a platform as a service, we also don't need to think about the operation system as well as a container runtime. We are just deploying our application to the web apps. So actually, platform as a service is about the web apps. So now we can compare a bit from advantages and disadvantages point of view, all our options that we just look at it. So, and first we will start with infrastructure as a service, and the first and the main, probably not main, but the first advantage of the IaaS is cost saving, because organizations don't need to worry about maintaining hardware and the network equipment, and as an organization we don't need to ensuring uptime and replacing old equipment. So having a third-party service to manage your infrastructure can save your organization a lot of money, actually. At the same time, we don't have to upgrade our software, we don't have to upgrade our hardware, our troubleshooting equipment problems. So it can be, as well as it can be scaled up and down quickly in responsible to the company's request and requirements. Also, infrastructure as a service offers strong reliability, allowing to configure an architecture that can survive even if some specific parts of your solution would fail or experience some outage. And in the same time, we have some disadvantages in this option. And first disadvantage is security. And I just put it here because the company or enterprise doesn't have any control over cloud security in the infrastructure environment. So this is the infrastructure and the network and the security. This is all the part of the responsibility of, let's say, of Azure. So, and we cannot affect it. So the company always needs to think and look at it if the policies and security policies provided by Azure following the security policies from the organization. That's not always the disadvantage, but sometimes it is. So software platforms or platforms are often updated or changed without any warning, which can be sometimes problematic, as well as you may not receive critical updates in time if something goes wrong. Also, organizations can face some downtime with infrastructure as a service during maintenance and patching, and it will restrict the access to the application and its data. And last one is having infrastructure as a service in the organization means that there is a direct dependency on the provider or third party for your data management and maintenance. So you always depend some organizations, so your data depends on Azure, so your data and maintenance depends of Azure, or maybe some other third-party companies that will manage it for you. But anyway, this is a dependency. So now we are switching to the platform as a service. And the first advantage, again, the reduced cost. And it goes from the following. So when you're using the PaaS system, real saving are possible since you don't perform low-level work yourself, and you don't have to hire additional engineers or pay for extra working hours. So you don't need thinking about the hardware, you don't need to thinking about the software. You are only focused on your application. So everything else will be done by Azure itself, or the engineers that are working on Azure side. So continuous update is an advantage of the platform as a service option, and it is, so PaaS expects continuously. So as a technology, so as an option, maybe as a model, if the PaaS expects constantly perform all necessary component updates and security patches for you to get that automatically. You don't need thinking about the update of your even operation system, so that will be updated automatically. And scalability of paths is provided by default due to configurable or automated scaling mechanism. And we still have some disadvantages, and one of the on the one hand, it is a great advantage that a certain part of work is done by a provider rather than the IT team. On the other hand, your business will still be governed by providers' functional capabilities, speed, and reliability. And as a solution scales out and introduces separation in application roles like Sitecore does for its connect roles, each role would have its own app service running in the path. And in contrast to the infrastructure as a service setup, these roles cannot be grouped together. So that may drive up overall costs. So in the conclusion, for example, in infrastructure as a service, we can group some roles, which is, for example, related to the XConnect, to the one virtual machine and run them all together. There are some XConnect roles that are not really high loaded, and they can exist with another roles, and they will not take a lot of resources. But in terms of platform as a service, you have to run each role in the separate web app, and you have to pay for that. So actually, it can also affect your costs. And the last option for today is a containers as a service. And it also has some disadvantages and advantages, and as far as we can see, there are a little bit more advantages, but let's look at it more details. And first, what I have put here is scalability. Kubernetes can scale the applications and the underlying infrastructure resources up or down based on your application needs. So we just can set the limits of resources that we want to allocate for some application, but when resources will not be needed for application, it will be automatically scaled down. And once we have some increased traffic on our website, for example, the resources will be automatically scaled up. So, and we don't need thinking about that, so it will happen automatically. Powerful CI/CD process. So this is also goes from the origin of Kubernetes. So Kubernetes provides like a blue-green deployments out of the box. So when we deploy a new version of application to our Kubernetes instance, the old one still works, and the old traffic goes to the old one, even the new one is running. So when we initiate in deployment, the new pod is created with new version of our application. And once Kubernetes will ensure that it works and healthy, only after that, all traffic will be routed to the new one, and old one will be terminated. So, of course, this is just one of the possible deployment strategies in Kubernetes, but it is most probably common, and which usually we use. So there is also powerful rollbacks provided by Kubernetes, and we can easily and quickly roll back our application, and we can create a new instance of our application, even the whole Kubernetes instance, every time when we need it. So that also goes from the Kubernetes. So when we are assuming that it's a stateless application and we can always run it from the beginning. So network encryption, Kubernetes utilizes TLS to encrypt network traffic inside and outside the host network. So cost optimization. So it seems like all Azure options have advantage related to the cost. But anyway, in AKS or Kubernetes, you pay only for the resources that were used, and resource allocation is automatically modulated to the actual application needs. So it means that, for example, at night, your business is stopped. You don't have any visitors on your website. You don't have actually any activities on your website. You don't pay for the resources that are actually. So we have used less resources and we pay less at night, for example, comparing it with the day activities when we pay more for because we have more traffic on the website, for example. So now we are switching to the disadvantages. And the first one is Kubernetes debugging and troubleshooting process. It requires experience and extensive training for each debugging and troubleshooting in due time. So from my experience, I spent really a lot of time when I just started working the Kubernetes. I spent really a lot of time trying to understand how I can debug it, how I can get some logs and what's wrong, why it doesn't run, and why it doesn't work as expected. So that was a really long way. That's just from my personal experience. Again, migrating from the alternate architectures. So this transitioning from the non-containerized application to the containerized application is not easy task at all. So because the build process can be drawn, so that can be done in a different way. So there is a lot of dependencies from the third-party tool that you use to build your solution. So, and it's not always matched to the build utilized with Docker containers. And sometimes it requires a lot of time just to be refactored or upgraded to be available, to be run in containers. And again, complexity converts to the cost. As I mentioned previously, Kubernetes is different to learn. This means that you will waste a lot of time if your team encounters any difficulties with the implementation and configuration, which will in turn bring high cost. That's very simple. Just again, from my experience, I have run maybe 5 Kubernetes instances, Kubernetes production instances already. And for the one customer, it was done like for the week, maybe faster. Just for another customer, when we just had restricted access to the Azure portal, for example, and it took like 3 weeks. So there is just the same architecture, but when you don't have just enough resources, it brings us in the time that we spent. It was 3 times more than for another instance where we have all required access. So I think now I can talk a bit about the deployment process. And this diagram explains the different approach how we deploy our application to the almost all options that you can utilize with Azure as well as the on-premise. And our application starts with some development, and when developer push code to the repo, some processes run some work on the Git side. So let's say the next step that is code analysis, but it is about the ideal world. So usually we don't have any code analysis in our repository, but anyway, it is possible. Once we have new code pushed to the repo, CI or continuous integration process starts, and it can be like a trigger which is running new build in our build pipelines. So it can happen when we just approve and merge our pull requests. So there are different options. It doesn't matter. We run as a result of our, when new code goes to the repository, we run new builds. So during the build, we perform some build tests, kind of from the ideal world again. So, but in the result, we have some artifacts that we push to our artifact storage. So once we have our artifacts, we can perform the release to our application, to our hosting where we run our application. Again, it can happen automatically once the build is ready and done. It can be manual process. So, but anyway, we have some pipelines which deploy our code to the Azure, or it can be even on-premise instance. So deployment testing and continuous deployment happen at the end of our way on a way from where code was pushed and the code goes to our application. So the current implementation of pipelines will be different for different options, of course, but the main idea will be as it shows on the diagram. So now I would like to explain. So, and I have similar diagram for the Kubernetes deployment, but before I will show it, I want to go through some details related to the Kubernetes. And this diagram represents the actual architecture of Kubernetes instance. This is maybe simplified one. So, but I want to show you how the Kubernetes instance, Kubernetes infrastructure looks like. On top of our cluster, we have, of course, Azure. We have resource group where we run our cluster. So, and before we run Sitecore in Kubernetes, we have to allocate some tools like Redis. We have to set up Solar Cloud, or we can use some services, SaaS platforms like Search Stacks, which is usually happen with Kubernetes. We have to set up some SQL server. Oh, sorry. So it also can be SQL, Azure SQL with some Elastic pools. Sorry. And once we have all third-party services, we create our AKS cluster, Azure Kubernetes Services cluster, and we can see two orange rectangles here. We have a Linux node, and we can understand node as a virtual machine because we allocate resources, hardware resources for the node. And actually, when we create our cluster, we select the size of this node. So, and when we're talking about the scaling up or scaling down the resources for our application, we're just talking about the resources that we allocate for nodes. each cluster in Kubernetes, even for any Kubernetes clusters, I mean, so it can be run in Azure, it can be run in Google or Amazon, doesn't matter. Each Kubernetes cluster have at least one Linux node, which is master, where some system information are stored and used by cluster itself. And we have Windows node, which is required for Sitecore, because Sitecore utilize the Windows images, and it is run on the Windows operation system. Actually, when we just talking with our clients about running Sitecore in the Kubernetes, they always ask us if Sitecore can be run in the Linux node. And when we just talking that Windows is required, they always a bit upset, because when the Kubernetes was go to our lives, it was about the Linux, and Windows is just parallel word of the Kubernetes. But yeah, so it is the requirement. And what we have in nodes, it is called like a pod, and pod is a smaller deliverable item in Kubernetes world. So actually everything what we do with the Kubernetes is finally will become as a pod. And actually looking at the Sitecore, each pod is represent each Sitecore role. So we have CM, CD, identity server, and this diagram as well. We have a rendering host. So, and all roles required for Sitecore Experience Platform for the XP1 topology, actually. So before nodes, we have ingress controller. By default, if you will use the specifications for Kubernetes provided by Sitecore, it will be Nginx ingress controller, but it can be different. So Nginx is just implementation of ingress controller. So, and it is used as a proxy server. So all requests from the outside, all requests outside goes to the Nginx ingress controller, and using some rules, Nginx or ingress controller route the request to the corresponding service or pod. So not all pods can be accessible from outside. So for example, we don't need access and processing from outside, but communication between pods possible on the networking level. So all pods can communicate with each other, but from outside we can go to the pods defining in the ingress controller. So we just add rules usually based on the host names, and depending on what you have in your browser line, so you will be pointing to the pod that you want to go to. So this is about the architecture in Kubernetes. So here, a few words and how we actually define our infrastructure for Kubernetes. So if you will go to the Sitecore website, you can download the package, which will include the files that you can see on the screen now. And those files explain or define your pods actually. But on the previous diagram, that was about the XP1 topology. And on the current screenshot, we have the definition for XM. So we don't have all Kubernetes, for all XConnect stuff here, only three main pods will be created: CM, CD, and identity server. And so actually this is just the YAML file with some specification of and allocation of resources that are required for run this pod. So that kind of Kubernetes syntaxes is used. So that's presentation not about the Kubernetes. I will not open all of them right now, but I just want to mention that we have some folders here that sometimes important to understand what they do. And actually we have external folder, which include some definition for external services. So on the previous diagram, I showed that we have to run SQL Server, we have to run Redis and Solar as a third-party services. That's a preferable way to run it for production instances, but for non-production instances, we can run it within our cluster as well. But of course, we have to understand that it will require additional resources. So, and if you will just look at the Sitecore documentation, they, for example, say that we have to utilize the node of size X, but this is in terms of we utilize the third-party services. When we want to run, for example, Solar and the SQL Server within our node, as well as the Sitecore instance, we need to understand that we need more resources, and the node with the size X will not be enough. So actually, we sometimes need a node with double size X, so which increase costs in 2 times. But yeah, that makes sense, because when we don't have enough resources, it will not too obvious. Sitecore instance or Kubernetes just don't run, but it requires some time to understand that it doesn't run because of lack of resources. So sometimes there are some just errors, something loads very long time and you don't understand what's happened. So for my first Kubernetes instances, it took like maybe 2-3 hours just to understand that I don't have enough resources. We have the customization files here. There is no mistake. So look in the English language, we have to write it with C, but in terms of Kubernetes world, let's write down with K. So actually it defines this file actually overrides, for example, images that we define in our main specification. So it is used just to don't override the original file. If we need just to update the image, we update this customization file and apply it. And we don't need to manage and rewrite the main stuff. So that simplifies the process of upgrade. If you want to, if the Sitecore will provide, for example, new files for your Kubernetes instances in terms of any patching or hotfixes, you don't need to compare it. We just override the main part, and customization will still apply your custom changes for your pods or for your specification. We have the ingress controller. This is files where the ingress controller is described. So also it includes the rules that I was said about before when I was when we just tried to match our host names with some pods. That's all is required is placed in the ingress YAML file. There is init images. Come on. Okay. We have, once it is loading again, we have init images. These images is utilized to initiate our databases and Solr indexes. So it is actually important part of the Kubernetes Sitecore setup process, because with Kubernetes, we always think about the stateless, and we actually don't have to install, for example, SXA package directly to our Sitecore instance as we usually do that. So we just prepare in new init images with additional items added to this image. And when we will initiate our databases, those databases will include this package items and files already. So, and when we will run a new instance, we will have this so SXA, Horizon, for example, and any other Sitecore modules added to the instance to our solution out of the box. So by default, Sitecore provides this init images just with the Sitecore items that we need to be just to run this empty Sitecore instance. Then, depending what you need on your solution, particular solution, you just build a new images based on top of the Sitecore one, and add there all required stuff that you need for your solution. And we have two images here. It is one for Solr and one for SQL Server. So Solr creates indexes, and SQL Server script will create your databases. So, and we have overlays. Overlays is used for, again, to override existing definitions. So, for example, if you need to make some changes for CM in terms of our custom solution, we don't need to update it directly to the spot. We can add some overlays and add additional maybe environment variables or something what you need for your CM server just to add a new file, which makes upgrade process easily again. So we have overlays. This is for search tags. We're updating our Solr init image with additional parameters, environment variables. We have some secrets definition here, and volumes is used for for creating a new persistent storage. So that's just a specification, a few file specification, and also interesting there. There are just one command that you need to execute to add this persistent volumes to your Kubernetes instances. Actually, what we have to do with all this stuff, we just need to perform a few commands. All these commands I got just from the Sitecore documentation provided on the website. This is a bit simplified way. There is no make sense just to stay a long time on this command. Just in a few words. First of all, we create EKS cluster. Then we have to connect our PowerShell to this cluster, our local PowerShell, and everything else that we will proceed with our cluster, we just do from our laptop. So you actually don't need to go to the Azure portal website, and we can proceed everything from our local machine. And then first of all, we deploy ingress controller to our cluster. I just put on the commands that you have to execute. So all these commands, you can see that it is applied for folders that we showed before. So then we add the secrets, deploy external data services. This is optional step, and it is required only for non-production instances. Then we just deploy initial images, persistent volume claims, and finally we just deploy Sitecore itself. So first time it took a really long time just go through this command, because when you download your documentation from Sitecore site, that describes this process very well. But sometimes there are just a few scripts that you need to copy from documentation and run on your local. For example, the script that will create SSL certificates for your cluster that will be used to communicate between different pods. And that's really simple script. And you just need to copy, put it to the PowerShell and run. You do that actually, and it doesn't work. So you spend a lot of time trying to understand why it doesn't work, but finally, you just have to run the script in the command line, not in the PowerShell. So that's a very simple example, which takes a lot of time to understand why it doesn't work in PowerShell, but finally, it doesn't work in PowerShell at all. So, but there is nothing said about that. So some scripts just have their own encoding, and when you copy to the PowerShell and run, it again doesn't work because one symbol looks like correct, but finally it has a different encoding. And yeah, of course, sometimes you just need to put it to the notepad and look at the different encodings, understand what's wrong. So if you don't know about it, you can really take a lot of time just to run this instance, the first instance in Sitecore. But the second time, all these tasks can take like 20 minutes and you have Sitecore running in the Kubernetes very, very fast. So, but that all is about empty Sitecore instance. There is no custom code yet. So, and actually what we have to do to run our instance, how we can add custom code to the Kubernetes, to the images. This is something which usually called like creating new images on top of the base images. So, and this definition always was confusing me. What does it mean create a base? So to create images on top of the some other base images. Of course, during the time I understand it, but now I want to explain it maybe for you. And if you will look at our images provided by Sitecore, which will be base images for us, creating our custom one. So we will see that there are just the windows, and Microsoft provides the different base images for applications required, and we have like a Windows Server core, which is usually used for most of the applications that are based on the .NET framework, not on the .NET Core, and actually Sitecore use it. So we have another server. It is this image will have less weight, but this is for .NET Core applications, and you cannot run your ASP.NET application like Sitecore on the Nano server, but of course you can implement some module running on the .NET Core and create image based on the Nano server. We have Windows and Windows Server. This is like almost full Windows images that you don't really need to use because they are really large. So for example, the image which is based on the Windows Server core can take like 9 gigabytes. So, but the good news that you just need to download it once. So this is the origin from the Kubernetes. So all base images downloaded separately, and if your 10 images just based on the same Windows Server core, you will be downloaded only once, and next time it will be used for all of your images based on the same image. So let's look a bit in detail. On top of our Sitecore images, we have Windows Server Core. Then we have Sitecore, which adds some website, Sitecore web root file to your image. Sitecore adds some scripts that create and run IIS on your image, and it also adds some dev tools, which is utilized, for example, for config transformations. And finally, we have our custom image, which is already based on the Sitecore's one. And what we actually do, we just add our project-related assemblies and DLL. We have to add some custom config files, and we can override some existing Sitecore files. Everything what we usually do with our Sitecore solution. So again, if we will look at the empty Windows Sitecore image, we will see just two folders, program files folders, and users, Windows, and license 6. So that's what we have originally. Then, if we will look at our Sitecore image, we will see that we have much more files here, and the Sitecore adds already in a pub folder where our application is put. It adds some tools. It adds some folder for transforms, scripts to run our Sitecore instance. So that's what we can see inside of the Sitecore image. And if we look at the initpub www-root folder, we will see our files that we usually see within our Sitecore instance. And now this is the time to look deeper to the deployment process related to the Kubernetes. And from the left side, we still have the same. We have a developer who push code to the repo. We have code analysis here, so which is run the CI process. And once our build is run and the result of the build will be pushed as an image to the Kubernetes, to the Azure Kubernetes registry. So the Docker build is utilized. So Docker is used as a tool to build our custom images, of course. And we can see that our custom images are built on some Sitecore-based images. So once build is ready, we push our custom images to the container registry. It can be Azure Container Registry, of course. It can be any private or so the only container registry from the another providers anyway. And this is like similar to the Azure storage. And once our build is ready, the release pipelines will be run. Again, it can be run with some trigger, it can be run manually. And what actually we do, we just push new Docker images to our Kubernetes cluster. But actually, we just send the command to the Kubernetes cluster to get latest images from the Azure Container Registry. So we don't push any images here. There is just a command for our pods to update their images. And once we send this command, our pod will look at the container registry. If version of latest image is different with the image that are currently run within the pod, it will download it will pull in the latest one and update itself. So this is how the deployment looks like. And again, if you will run deployment without any new containers which is pushed to the container registry, the deployment will do nothing. So actually, it will not take really long time. It will just check that nothing new in the container registry and skip the deployment. So this is a bit different with the deployments to for example, to the IIS, where the deployment will happen anyway, even you don't have any changes. So this is a slide about the GitOps, and this is from the DevOps world. And the GitOps is it is not a tool. It is like a paradigm or set of the practices that takes DevOps best practices used for the application development, such as the version control, collaboration, compliance, and CI/CD tooling, and applies them to the infrastructure automation. So what actually GitOps can do? It is used to automate. The main reason of GitOps is automate the process of provisioning infrastructure. So usually GitOps use configuration files stored as a code, or in another word, this is an implementation of infrastructure as a code approach. So, and GitOps configuration files generate the same infrastructure every time it's deployed. So as well as your application source code generates the same application binaries every time it is built. So which means that every time we deploy the same configuration or the same definition of our infrastructure to the cloud, it will, as a result, it will have always the same infrastructure. So even if you will change anything on the in Azure manually, it will be reverted to the state defined to the state defined into it in configuration file. So everything what we have done to run Kubernetes according to the documentation provided by Sitecore is a manual steps that we run on our local, and there are no automation out of the box. And automation so definitely comes to within GitOps definition, and there is two tools that utilized by Sitecore in terms of Sitecore Managed Cloud, and it can be utilized with any DevOps definition and activities in your company. And if you want to utilize like GitOps approach, so which is defining your infrastructure in Git or any other storage. So Terraform and Ansible, there is two tools that usually used. So I think usually, I'm not a DevOps engineer, so, but this is very seems like the most popular things, tools, and they're a bit different but do the same actually. Terraform uses a declarative approach to deal with infrastructure management, which means the user sets the end state of infrastructure as a Terraform, and Terraform performs the actions necessary to set up and maintain that state. So actually we define, you create some configuration, and in configuration files you define and describe what you need as a result of execution, and based on this configuration, Terraform performs the steps that required to achieve that. So in the same time, Ansible is a procedural approach, utilized procedural approach where a user defines the steps that have to be done, that need to be done to desire to achieve desired state. That means it is best suited for adding installations or application changes on top of the existing networks. So, and what actually Sitecore do, they use Terraform to define the application level. So to defining the size of your nodes, for example, the number of nodes, the number of so actually everything which is related to the Kubernetes and cluster itself is a configuration, is a part of the Terraform configuration, and Ansible used to deploy our custom images and is used to run Sitecore itself. So we finally got the Sitecore Managed Cloud definition, and this is a hosting service that enables customers to deploy various of Sitecore instances, which can be Sitecore Experience Management, Topology XP, and even Commerce, Experience Commerce, on the Microsoft Azure cloud. It is the alternative to run the Sitecore platform on premise or on any other public clouds. And with Sitecore Managed Cloud, Sitecore actively monitors, manages, and maintains both the infrastructure and applications levels of your application. That means that if you run, for example, your application in the past, Microsoft Azure is kind of responsible for your infrastructure, but they don't have any access or understanding what you run there. But for Sitecore Managed Cloud, Sitecore also responsible for the infrastructure, but they are responsible for the kind of your application. So they, of course, cannot guarantee that your custom application will work, but at least they are monitoring that. And if something's wrong with your application, some logs have errors or something's wrong on the monitors, or some charters, they will take that into account and try to proceed that with some actions. So managed cloud can be based on the PaaS or Docker containers. I have the experience only with Docker containers. And within managed cloud, the customer will get some advantage of support. So that will be like almost 100% of SLA. They will get like a very so that maybe not very, but quick enough response for the issues. So yeah, that's there is another advantages, but of course this is something that Sitecore does from their side. And from the development point of view, this is just the Sitecore Managed Cloud is Kubernetes cluster that Sitecore created for you or for your client, and they get access to. So you have access from the PowerShell, it is described before, so you can execute any commands on the cluster. So, and this is kind of good experience to work with. So I will say a bit more words in the future slides. And how the deployment to the managed cloud looks like. Again, the left side is pretty the same as for the standard Kubernetes instance. We still push our custom images to the Azure Kubernetes registry, but this Kubernetes registry are hosted on the Sitecore subscription. So we are pushing code to the Sitecore to the Azure subscription running by Sitecore. And then we have deployment pipelines also running in the Sitecore subscription where we have access to as the developers. So all developers that are working on the project and require this access will get it. We just need to create a new support ticket to the Sitecore, just asking them to provide access for some people. And then we don't use any commands, so we don't communicate with the cluster directly. We use Ansible as a tool to run deployments. So, and we just say Ansible to proceed, and it will create everything you need, even from the beginning. I'm trying to speed up a bit just to looking at the time. And of course, we have a list of pipelines provided by Sitecore. So, and we can see that I made this screenshot based on the project that are actually in live state for maybe 4 months. And you can see that only part of them was used actually. And here, 2 main pipelines that we will use to deploy our code to our Sitecore instance. It is application and infrastructure. They are mainly used. Application pipeline deploys new images to the cluster, and infrastructure just update the existing infrastructure with your changes that you probably need to proceed. For example, if you want to set up the limit of the number of nodes that to be scaled up to some value, you need to update the configuration. Then you just need to proceed deployment with the infrastructure pipeline, and your Kubernetes instance will be updated. So we have some pipelines to upgrade our cluster version. So it is a separate pipeline to deploy the front door. So in case you add some new host names to your application, so you need to update your front door to be able to proceed to route traffic to your cluster from outside. So this is also the configuration file that you just need to update to proceed with that. A few pipelines that was never used by me, at least. One of them looks useful, which will update the core license. You don't need to asking how to update the license, it will be updated for all roles. So another one, so the rest of them looks like a system administrative pipelines that will be used in case of any disaster with your cluster. So very short demo. I see that we don't have time, just maybe 3 minutes and I will finish. Just a second. I will find required. Yep. Okay, when you just decided and so your customer decided to work with the Sitecore Managed Cloud, you will get access to 2 repositories from Sitecore, and one repository called like application, another called like infrastructure, and each of them is represents actually the infrastructure and application level. Infrastructure level repository is used by Terraform to proceed with infrastructure provisioning. And of course, you have the definition of pipelines. Here you have actually the definition of front door, and if you need to add some additional, for example, rules for your front door, we will update it here and push this code to the main branch and run a new deployment of pipeline that I showed before. So, and your changes will come to the cluster actually, and to the infrastructure. So there is quite a lot of files that we can change here, but from my experience, we just updated the number of nodes for our instance, and that's only one change that we done with our cluster, and we haven't touched this repository anymore. And all this process is very well described on the Sitecore documentation. So everything which is most related to the Sitecore Managed Cloud was very good explained with some examples in documentation, and it was pretty fine. Another repository is applications, and here we described actually our solution that we are going to deploy there. And for example, we have added a new component to our instance. We have added horizon and rendering host, which is explained and defined. I will try to look at it. So here we just explaining which environment variables we need, which image used for our rendering host. Actually, this image is just the name of our image that we have pushed to our Azure registry. So all this stuff is very similar with the definition of Kubernetes or Docker on local machine, but just in different syntaxes. So, but of course, that's also described, and probably the main file that we will change is Docker images. This file is defining which images will be used with our cluster. So, and for example, you run new build with your code. As a result, you push the demo image with, for example, this one tag to the Azure registry. And if you want to get this image pushed to your cluster, you just need to create a new branch from main branch of application repository, update it, and create a pull, update it with corresponding version of image, and push your pull request to the main branch again. And once this pull request is approved and merged, which can be approved and merged by you as well, so that will be deployed to the cluster. So the main concern here that you have to specify the exact version of image to be deployed there, because if you will use just latest, which is common for some Docker stuff, you can always use latest to get latest image from the repository, from the container registry. But for Sitecore Managed Cloud, it doesn't work because Ansible does not understand if something was changed with your image, and when you will just put latest, it will not deploy anything. So because it always understands that latest is already deployed. So that's strange. We created a Sitecore ticket, but they haven't changed. They cannot change anything with this flow, unfortunately, yet. So that's how our deployment looks like. We have custom image. We define the custom image for, instead of the base one, so which is, for example, for Sitecore Horizon, we use like Sitecore image without any customizations. We can see just this image from Sitecore container registry. By default, there was all images going from the Sitecore registry, but we have replaced them with our custom images because we have added something everywhere. And then we just need to specify a specific version for image to be deployed to Kubernetes. So that's how deployment process looks like. So I think I will end up with the presentation. In a conclusion, I just wanted to say a few words about my experience working with the Sitecore Managed Cloud. And I can say that there is no ideal hosting for all environments and for all solutions. Each solution requires some specific approach, specific environment, and we always need to think what is better. So Sitecore Managed Cloud looks very, very good. So I got a good experience. Sometimes it was difficult because if you need to make any changes in terms of your cluster, I mean, on the Kubernetes level, you have always create a new ticket with Sitecore system. And just in case, for example, we have the init images running on our Kubernetes instance. I was explained that they used to add new databases and new solars initially. And actually, these scripts can be run only once. If you will try to execute the same init images to run the same init images, usually they will not do anything. But in the Kubernetes stuff, because they utilize the Terraform and Ansible for deployment, they will say that init images was applied and they cannot be applied again. But for example, you decided to use the Managed Cloud, and you want to, and as an input, you will get Sitecore already running on your cluster. So, and this is the point where you have got access to the instance. But you decided to use SXA, for example, and you need to update your init images, and you have run these init images from the beginning, but you cannot do that from the beginning because you have already Sitecore run in your cluster. So then spending some time trying to understand how we can do that. So we got that we cannot do that. We write a new ticket to the Sitecore. They say that yes, you cannot do that. They have done something with the cluster, and just in the next day they wrote the message that we can try to run this script again. Initial images, I mean, so, and that was working, but initially that was not. So each issue that you will face with Managed Cloud, you have to create a new Sitecore tickets and try to figure out how to fix something with them. So this is just extra communication that you have to go through, but in general, that was a good experience. So that's probably all, and thank you for your attention. And sorry that it took a bit longer than expected.
Thank you, Artsem. I had a couple of questions in the chat to start with.
Yeah, I'm looking at it. So,
Kiran, feel free to talk if you need to.
Detailed.
Yes.
Wow.
So we didn't use Managed Cloud, but we had infrastructure as a service, and we went down the route of containers. And it's been a long, tedious process. But one of the pain points we had along the way was the SQL init scripts, and we didn't use them right away. We used the initial images to move forward, but then we always kept circling back to Sitecore asking, can you give us, or did you use these init scripts or not? So I just want to understand what their function is and if there's any like more detailed documentation available to kind of understand what function they serve, and is there a way around them if you missed them initially?
Actually, I haven't found any detailed documentation explaining how to create some init images on top of the Sitecore one. So, and if in terms of the Sitecore images, that's more or less understandable because they just have a website, the root of website where we just add a new files, but with the SQL server it's a bit different way. So yeah, I also spent a lot of time just to investigating how it works, and I was looking at the images itself, looking at what file they have. So actually, I have created the custom init MS SQL init images, but that was not too easy. So yeah, but yeah, and we don't have any documentation, unfortunately.
I figured I'd ask you, since it sounds like you've kind of gone through this in the process. You found a better way.
Yeah, one thing we have used init images specifically, we used it when you need to make some database related changes. For example, if you need to do Coveo installation or any specific package that has a database file, and basically in this SQL init, we were just executing that and ensuring those database related changes are taken care of.
Okay.
So we did need that. We did need that for certain package layering, I would say.
Thanks, Father.
Okay, Sanjeev, you had a question?
So there are a few, I see the subscription-based registry is being used. One of the question I had, like if you had to maintain any new changes to the infrastructure which is not coming from Managed Cloud, did you have an IAC code in your repo so that you can rebuild, or if in case of disaster recovery, you can rebuild those resources in Azure? Were there anything like that? But I'm sure that whatever Sitecore provides in Managed Cloud might be sufficient, but there might definitely be some additional needs which you work on.
Actually, in terms of any disasters, I don't think you can do anything with the cluster itself, because that all should be done by Sitecore, because you don't even have the admin access to your cluster. So, so everything which has happened with cluster in terms of Sitecore Managed Cloud, this is the responsibility of Sitecore, not by you. So, and yeah, so that provides some difficulties because sometimes we had to recreate some pods because of some unexpected behavior of that, and we was not even able to delete one pod, which is very standard operation with Kubernetes. When you delete the pod and it automatically recreated, so that we can understand like a restart of your pod. So, but we was not able to do that without any request to the Sitecore. I don't think you can recreate your cluster by your own. So you can, of course, increase, but no, you even cannot scale up your node because the size of your nodes is a part of the agreement with Sitecore. So you cannot just simply increase or scale up your nodes. You can negotiate it with Sitecore anyway. So if you want to more resources, you even maybe need to sign up a new agreement for upper plan maybe, or so some additional costs for new size of your nodes. So that's everything what you want to do with your cluster, you have to do with Sitecore.
So, okay. I was talking about infrastructure as a code. So you said there are no changes. It's all Sitecore, and they will have to handle via ticketing process. And if you want to scale more, you go back and up your subscription. Is that how you handle?
You can scale up your node, and actually I have done it. But
Okay.
before I have discussed it with Sitecore if I can do that.